Uh, Welcome to the second live session for Wave Optics course. So I'm Rohit Kumar Singh, the teaching assistant for this course, which is being taught by Dr. Samudra Roy from IIT Kharagpur. And we already had one session last Saturday where we discussed basic things about waves and how electromagnetic waves uh, behave and I mean how to understand the equations of electromagnetic waves and uh, what are the criteria of equation to become a wave and things like that. So now today we will discuss similar things. So in the second week we have this superposition of waves and the concepts of group velocity and phase velocity. So I'll quickly recap those concepts and then we will solve some problems based on them. So does anyone have any question from last session or any general item that you want to discuss before we start? So feel free to unmute and interact, ask question, or you can also write it in chat. So that I get real time feedback. Okay. So if everyone is okay, then let's move. So so yeah, we discussed about waves. Now let's discuss the superposition of waves. So what happens when two or more waves are there in any medium? So we will basically concern ourselves with sinusoidal waves or harmonic waves. So if we have two waves, how do they interfere and how do we understand the superposition of them? Okay. So let's say there are the two waves are represented by these equations. So we are fixing the position of these waves. Okay, you can see there is no space dependence in the cos here. So we will assume that we are looking at the waves at a fixed point on the z axis. Okay. So this is the first wave, and then you have a second one x2. Okay, with amplitude a2. Frequency will be same. Okay. So what is the difference between these two? These two waves, like, first thing is the amplitudes are different, right? And the phase is different. Okay. So if you would like to draw it, you will get something like this. So suppose so this is your, so it's a bad drawing. So this is your x1 at time t. Okay, and this is your amplitude a1, and then and suppose yeah, let's shift it with theta. So that shift you can represent it like so. So suppose this is a shift. Okay, and then you have the second wave which is shifted by theta 2. Okay, and so it can be like something like this. Okay, and this is a larger shift and its amplitude is A2. Okay, so this will be your x2. Now what happens when we superpose them? Okay, so mathematically what will happen is because when you are superposing them, it's basically, so waves are disturbances, we studied last time, right? So waves are just disturbances which is whose magnitude is given by this x. So what will happen is when you do superposition, you will just add up the disturbances, right? x1 plus x2. So x at any time t will be just x1 at any time t plus x2 at any time t, which in terms of our definition above you can write omega t plus theta 1 plus a2 cos omega t plus theta 2. Okay, so this is the superposed wave, equation of a superposed wave, okay, with different amplitude and different phase. But this doesn't give you much information, right? It looks like just another wave, but what you can do is you can expand it. So you know cos A plus B formula, right? Cos A plus B, you can use it. So cos A plus B is basically cos A cos B minus sin A sin B, right? So you can use this in the above formula, and what you will get is this result. So A1 cos omega t cos theta 1 plus A1 minus sin term will be there, minus sin omega t sin theta 1. Okay, and for the second term we will get A2 cos omega t cos theta 2 minus here A1 will be there, here A2 sin omega t sin theta 2. Fine. Now you can separate the cos and sin terms. So if you take cos omega t outside, you will have A1 cos theta 1 plus A2 cos theta 2, and minus you will have sin omega t. If you take outside, what remains is A1 sin theta 1 plus A2 sin theta 2, right? And now what you can write is so now you see this is a cos omega t something, then sin omega t something, right? And if you substitute in these instead of this bracket, so let's say you substitute a cos theta minus sin omega t is there, and you substitute a sin theta, okay, where a cos theta is nothing but a1 cos theta 1 plus a2 cos theta 2, and a sin theta is a1 sin theta 1 plus a2 sin theta 2. Okay, then what you get finally is, so this is again a form of sin a plus b, rather cos a plus b. So this is cos omega something cos theta cos omega sin omega t sin theta t. So you can write it taking a common, you can write it a cos omega t plus theta, right? So what you finally get after superposition of two waves is another wave, okay, with a different amplitude A and a different phase angle theta, okay. So two waves combines and give you another wave, okay. It's not like that they are they are independent of each other anymore. And similarly, if you combine 3, 4, 5, you will get just a single wave, superposed wave with a different amplitude and different phase angle, okay. And this A and B you can simply calculate. So from these two formula, if you square it and add it, you will get A square. So on the right hand side, cos square plus sin square theta will give you 1. So you will have just A square, and on the right hand side you will have A1 square plus A2 square plus 2A1 A2 cos theta 1 minus cos theta 2, okay. This you can get from these two equations, okay. You will have to use this cos A minus B identity. So cos A plus B was this thing, sorry, cos A plus B was this thing. Cos A minus B is the similar, just you will have a positive sign in the middle, okay. Is everyone fine with this A square formula? You have to just square these two equations and sum it, okay. Take the square and sum them, right hand side and left hand side separately, you will get this formula. And for the theta, the new phase angle, you have to just divide them. So what you will get is, you divide the sine with cos, you get tan theta, right? A and A cancel, and tan theta will be equal to A1 sin theta 1 plus A2 sin theta 2 and A1 cos theta 1 plus A2 cos theta 2. So from these two equations you can get the amplitude and phase angle of the superposed wave, okay. So we will see some problems based on this formula. Is everyone fine till here? So just a basic calculation. If anyone has any doubt, you can ask, or if anyone is not comfortable, I can again explain it. So what we did is we took the two wave equations, okay. We just add them using some simple trigonometric relations, okay. We arrived at a new wave which has a different amplitude and phase angle given by these two formula, okay. Okay, so if everyone is okay, then it's fine. So this is the concept of superposition. Now what happens when you have two waves with a slightly different frequency? So here you saw that the frequency of the two waves that we superposed was same, okay. So but this cannot be a real life scenario, right? In real world, all the light that you are getting, so from a bulb or something else, so the frequency is different, okay, for different sources of light. Now how they combine with each other? That is a genuine question you can ask, right? So this is a very ideal scenario when you have a coherent source of light having the same frequency, or the phase difference is also constant between them, then this scenario works. But when you have sources of light with slightly different frequency, then this will not work. Okay, so there comes a concept of something called a group velocity. Okay, so now instead of a single velocity that the superposed wave is traveling, you will have something like a group velocity. Okay, so let me explain what I mean by group velocity. So group velocity, now suppose now you have two waves. So now I'll write the dependence on space also, because we will need them. So you have two waves. One is given by a cos omega plus delta omega. So this delta omega is a small change in the frequency. Okay, and here the wave number is also changed by a delta j. So don't worry about this. Just we are I'm writing it so that to have two waves with a difference of frequency. Okay, and if the frequency is different, then the wave number will also be different. So that's why we have this. And the other wave will have a omega minus delta omega frequency. Okay, so now these two waves have a frequency difference of 2 delta omega, right? And similarly I can write delta minus k minus delta k. Okay, so now here you had two waves with same frequency, but here we have two waves with different frequency. Okay, and the difference is 2 delta omega. Now what will happen when you superpose this? So as I showed earlier, superposing means you just add them up, psi 1 plus psi 2. Okay, so adding them, let me write it. So if you at any point you don't understand anything, just stop me and ask any question. Here we are keeping the amplitude same, but that can also change. It does not matter much, because now our focus is on the frequency. What happens if the frequency is different? Okay, so these are this is the superposed wave. And okay, now if you work it out, you use the same relation cos a plus b and cos a minus b. So it will be a little longer, little long term, and many things will cancel out, but what will remain is this quantity that I am writing. So you will have 2a cos omega t minus kz multiplied by cos delta omega t minus delta kz. Okay, sorry, yeah. So this is your superposed wave. Now you see, this is very different from what we got here, right? We got only one single cos function, but here you see there are two cos functions multiplied with each other. That means there are two waves which are somehow multiplied into each other. So what does that mean? How do you interpret this kind of wave equation? So to interpret this, let's first draw them separately. Okay. So first let's draw the the first cos function, and then the second cos function. Okay. So yeah. So this is a, and we are drawing them at a fixed time t. Okay. So you will get, sorry, this is a cos function, just I am drawing it very badly. Let me try again. Okay, so something like this. So this is cos kz. So I am drawing it at a fixed time, and this one at t equal to 0 will have something like this. It will be so this is a cos delta k j. Okay, because this delta k is smaller, right, than k, so this the frequency, I mean the, yeah, you can say the frequency is higher here, and this is the frequency, and this frequency, because this is delta omega, we have assumed is smaller than omega. So we have assumed delta omega smaller than omega. Okay, everyone is fine with this? So I have drawn these two functions differently. Now what happens when we combine them? Okay, and how to combine them? So to interpret this together, okay, you have so one thing you will notice, this function is varying very rapidly, right? This is its frequency is high, so it's varying very rapidly, whereas the second one, so when we are adding them, the second one is varying very slowly. Okay, so what if we merge the second one into the amplitude of this whole wave function? So what if you define a new amplitude a prime, which is given by this formula? So you are combining the second wave equation into the amplitude. So if you write it like this, if you define a prime like this, then your psi, the superposed wave, will be a prime cos omega t minus kz. Okay, and this is we are familiar with, right? This is what we got, something like this here. And so but how do we interpret this thing? Okay, or how do we represent this? So I'll just draw it, okay, and then I'll tell you how it is interpreted. So you will have, again my drawing is bad. Something like this, and then again, okay, so you see it has an envelope, right? It has an envelope like this. So because this magnitude, this amplitude a prime, it's varying like this function, right? But the wave is the wave actual wave is which is a fast traveling wave. It is varying like this. So when you combine this, you will get something like this. Okay. The superposition of the two waves, basically with different frequency. Something like this you will get. So and this is that's where the concept of group velocity comes in, because now it has no longer a single velocity. Okay, it has a group velocity. And so first of so the velocity of this uh, you know wave, which is called the phase velocity, is nothing but omega by k. But this whole packet, this whole envelope, it is moving with a different velocity, which is called group velocity, and which is given by delta omega by k from this equation. Okay, and this is called group velocity. Is everyone following? Let me know if you have any doubt. So this is the basic idea of group velocity. When you have different two waves with different slightly different frequency, you then no longer a single concept of velocity applies. You'll have a group velocity. Okay. Similarly, if you have three waves, four waves, then all of them combine, and you will get another you will get a unique group velocity. Okay. You will learn that later, maybe in quantum mechanics. There is something called wave packets. So when you combine many such harmonics together, you get a wave packet. Okay, and which moves with a group velocity. So that is a concept for later. So right now, this is what group velocity means. Okay. Is everyone okay till here? Any question? If not, then okay, then let's discuss one more important thing, which is what happens when what happens when there is a medium. So you are talking about a light. I mean, now we are talking about electromagnetic waves or light. Okay, and what happens when there is a medium? So I just wrote the formula for velocity, phase velocity, which is just omega by k. Okay, and so for electromagnetic waves, we know that this velocity is basically c, right? The speed of light. But this is in vacuum. When you have a medium, you have to divide it by the refractive index of that medium, and this refractive index, it depends on the frequency of the light. Okay, so it is not constant. So this is the formula for a phase velocity of a light ray or light wave, whatever you call it, in a medium with refractive index n. Okay. Now, what about the group velocity? So we just saw the group velocity is nothing but I mean, when we had two waves separated by delta omega, we had this formula, but you can get it infinitesimal smaller. Okay, and you will reach to a differential form. So you can write it like this. Okay, so when this delta omega tends to very small change. Okay, so this is happens when I mean in a real life scenario, when you have a light coming out from a bulb or something else, this is what happens. All the light pulses, they have very small difference in the frequency, and the group velocity for those is defined by this. Okay, and so you can take this formula which is now which you can so first you can invert this, so you can write it like this: 1 by group velocity is dk by d omega, and from here you have k is equal to omega by vp, which using this formula you will have omega n omega by c, and yeah, okay. Now if you do this differentiation with respect to omega, what you will get, so because here the n is also dependent on the omega, you will have to differentiate it also with respect to omega. So let's do this. So dk by d omega, basically first let's we will do it in two parts. So if we differentiate d just omega, you will get 1. So what remains is n omega by c, and then you differentiate n omega, so omega by c is there, and then dn by d omega you have. Fine. And now if you see, if n omega is 1, which is true for vacuum, right, then Vg is here you see everything will be 1. This one will goes to 0. So and n omega is 1, and then you get Vg equal to c, which is nothing but the phase velocity. So for a vacuum, group velocity will be equal to phase velocity. But when you have a medium, this condition does not hold. Okay. So to get a relation between this group velocity and this refractive index, what you can do is you can use the free space wavelength of the light. So sorry, someone has raised hand. Anjali, you want to ask something?
Explain once again.
Sorry, no, please speak. Hello?
Hello, could you explain once again?
Yeah. Which thing? Like
From this formula, Vg is equal to delta omega, group velocity is equal to delta omega by delta k.
yeah. So okay. So this one you followed, right? This thing you followed, right? Till here. Hello?
Hello, am I audible, sir?
Yeah. So
am I audible?
Yeah, you are audible. I'm asking, this thing you followed till here, right?
Yes, sir. Yes, sir.
Okay. Now what I was explaining is, so suppose now you have for a electromagnetic wave which is light, okay, passing through a medium, the phase velocity or the velocity of light is given by this c by n. You know this, right? It is no longer
Yes,
c.
sir.
It will be it will depend on the refractive index of the medium, right?
Yes, sir.
And this refractive index, it depends on the frequency of the light. So that's why I have written it as a function of omega. Okay.
Okay.
And now we have this formula of group velocity from earlier derivation. And if this difference in frequency tends to 0 or it gets very small, you can write a differential form, which is just d omega
Yes,
by
sir.
dk. Okay, that is fine.
Yes, sir.
So and then we just inverted it, this formula above. Okay, and using this formula, wave vector, we can write omega by vp,
Yes, sir.
which is and then at vp we can substitute c by n. Sorry, so that's what we did here. Okay, and then we tried to then we differentiated this wave vector with respect to omega. We got this expression. Okay, is it okay?
Okay, sir.
And now what we see here is, if you are looking in a if you have a wave in vacuum, then the group velocity and phase velocity, they are the same thing, and it is equal to the speed of light c, because here the n is 1, so this one will be 0 dn by d omega. You get this, n is 1, and what remains is 1 by c. So vg is equal to c, which is we know the velocity of light, phase velocity. Okay, so if light is traveling in a vacuum, okay, there will not be any the group velocity will be same as that of the phase velocity. But if it encounters a medium, then because of this frequency dependent refractive index, okay, you will have the group velocity will be different than the phase velocity, and that I'm going to write how it changes. Okay, so in terms of this speed of light in vacuum, you can have the wavelength of light in a vacuum, which is which you can write it like this, 2 pi c by lambda naught. So lambda naught is the vacuum of light in lambda naught is the wavelength of light in vacuum. Okay, this is fine.
Yes.
Now no, dn by d omega, because you have to evaluate this, right? The dn by d omega, you can first differentiate it with respect to lambda naught, and then d lambda naught by d omega. So I am using this chain rule of differentiation. Okay, and so from here, d omega by d lambda you can calculate, right, which is nothing but, so this is 1 by lambda naught, so minus 1 by lambda naught square, right, and 2 pi c is there. Fine, and you can substitute that here. So you have lambda naught square by 2 pi c, and dn by d lambda naught will be as it is. Now using this relation, we can write the group velocity. So 1 by c we can take out, n remains, and we can write it because we till now we have written it as a function of omega, but since omega and lambda naught are related, we can write it as a function of lambda naught minus, and omega by c is 2 pi by lambda, so everything cancels out, and you will have just lambda naught here, dn by d lambda naught. So now you have the group velocity expression for a electromagnetic wave or light, okay, in a medium, as a function of the wavelength of light in vacuum. Okay. So this is a very famous expression, and we will many problems will be there on this in the tutorial assignment also. So make sure you understand how we get this. And then you can define something called, so this is group velocity. You can define something called group index or group refractive index, which is Ng equal to C by Vg. So for example, I mean, this is inspired from this formula. So phase velocity we had C by N. So this is the normal refractive index. Similar to that, we have defined a group index, which is C by Vg. It means speed of light divided by the group velocity of light. Okay. So, and this will be nothing but so from here C will cancel, so it is just N minus lambda naught dN by d lambda naught. So this is another simple expression, so for group index. Okay. So this is all. So let me know it's clear, right? Everything. Here lambda naught is nothing but wavelength of light in vacuum. Okay. Because we are learning wave optics, so that's why we just derived this equation for a for a light wave. Okay, so these things will become more clear when we solve some problems. Okay, so let's go to problems. If anyone has anything to ask till here, you can ask, otherwise we will move to examples. Okay, everyone is fine, then let's go to examples. Okay, so this is a very simple question starting. So question says a sound wave with a frequency of 1.10 kilohertz propagating with a speed of 330 meter per second. Okay, determine the phase difference between any 2 points on the wave separated by 15 centimeter. So everyone knows how to solve this, right? So you have a wave, sound wave or anything, and the question asks if there are 2 points. So let's say point 1 is here, point 2 is here, and they are separated by a distance 15 centimeter. What is the phase difference between these 2 points? Okay, so this delta x is 15 centimeter. You have to find delta phi. How to do this? This is a basic problem, from class 12th, 11th, 12th. Anyone remember? No one? So okay, I'll give you a hint. So you can not able to recall. Okay, no problem. So you have given here been given here the frequency and the speed of sound, right? So from here you can calculate the wavelength, correct? So wavelength is nothing but 330 divided by 1.10 kilohertz. So you multiply it by 1000, and what you will get is 330 divided by 11, which is 3 meter. Sorry, 30 meter. Okay. Is that correct, or I have done something wrong? Sorry, no. Sorry. Yeah, 33 by 110, so 0.3 meter or 30 centimeter. Yeah, 30 centimeter is the wavelength. Okay. Now you know that if any 2 points separated by a wavelength has a phase difference of 2 pi, correct? So if delta x is lambda, delta phi is 2 pi, then if delta x is 15 centimeter, what is delta phi? Simple, right? So delta phi will be 2 pi by 15 centimeter into 30 centimeter. Oh, sorry, other way around. Two pi by 30 into 15 centimeter, right? So delta phi will be pi. Phase difference will be pi. It's easy one, right? Everyone okay? Now you recall? Okay, thank you. So yeah, this one was easy. Let's move to the next one. Okay. Now here, this is one problem with superposition of waves that we discussed. Okay. So you have a wave equation given by this a minus omega t. So here a is a constant, so this is a phase angle. Okay, this is a resultant wave or a superposed wave of two different waves with amplitude E naught, so 3 and 4 centimeter. These are two amplitudes. So so basically A1 is 3 centimeter, A2 is 4 centimeter, and the phases are given. So phi 1 is, or in our terms, theta 1 is pi by 6 and theta 2 is pi by 3. So this is given, and you have to find the resultant. Yeah, you have to basically find what is E naught and A is. So we just learned this formula, right? So we can use these two formula to find this, correct? Everything is given. So the resultant amplitude E naught will be nothing but a1 square plus a2 square plus 2a1 a2 cos theta 1 minus theta 2, right? From this formula, and so let's substitute a1 and a2. So um, 3 square is 9 plus 4 square is 16 plus 2 into 3 into 4 will be 12. Will be 24. Yeah. Sorry. 24 into cos pi by 6 minus pi by 3 is again pi by 3 cos pi by 3, right? And cos pi by 3 is, anyone? Cos pi by 3 is under root 3 by 2, right?
Yes, sir.
Yeah. So then what we have is 9 plus 16 is 25 plus 12 root 3. Okay, now you will have to use calculator, and you will get something like this around, which if you take square root is 6.77 something. Okay, so this is the amplitude. Now, and for the phase angle A, what we have in the formula, this one, right? So we have to okay, let me write. So yeah, so instead of finding the tan theta, first we can find the A sin theta, which is a1 sin theta 1 plus a2 sin theta 2. Okay, sin theta 1 means sin pi by 6, right, which is 1 by 2. a1 is 3, so 3 by 2 plus a2 is 4, and sin theta 2 means sin pi by 3, which is 3 under root 3 by 2. So you will get so 3 by 2 1.5, and this one if you calculate it you will get 4.964. Similarly, you can find a cos theta, which is a1 cos theta 1 plus a2 cos theta 2. Okay, just put everything here, and you will get something like 4.598. Now if you divide this, what you will get? Tan theta sin theta by cos theta, this tan theta will be 4.964 divided by 4.598. Okay, and you can take tan inverse, so theta will be tan inverse of this quantity, which is 1.08, and it will be roughly 47.2 degrees. Okay, so yeah, so this is your A basically. So just using these two formulas that we have derived earlier, we can solve this problem. Everyone is fine?
Excuse me, sir. Is it cos pi by 3 or pi by 6?
Cos where?
In E naught is equal to root under a1 square plus a2 square.
So this is cos theta minus theta 1 minus theta 2.
Yes.
So cos pi by theta 1 is pi by 6, theta 2 is pi by 3. So you will have
Yes,
pi,
it should be half if it is cos pi by 3.
No. So yeah, it will be basically cos it will be cos minus pi by 6, right? And cos minus pi by 6 is just cos pi by 6, which is under root 3
yes,
by 2.
sir. Yes.
right? Did I say cos pi by 3? Sorry.
Yes,
Yeah,
pi by
yes.
3. That's why I
No,
got
no, 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 sorry. So yeah, it will be cos minus pi by 6, which is just cos pi by 6, which is under root 3 by 2. Fine. Thank you for pointing it out. So other than that, everything is fine, right? You'll have to use calculator
Yes,
for
sir.
these calculations. Yeah. So okay, then let's move to the next problem. Yeah. Now instead of two waves, now we have three waves, and we have to find the superposition of these three waves. But idea is the same. Okay, if you have 3 or 4, doesn't matter. Okay, you can use the same formula. So the general formula is this. So A is basically uh, sorry, yeah, I mean the A cos theta is basically A1 cos theta 1 plus A2 cos theta 2 plus A3 cos theta 3, right? Which you can for if you have n numbers of waves, you can write it in a summation form, ai cos theta I, and we have the second equation, which is a sin theta, which is a1 sin theta 1 plus a2 sin theta 2 plus a3 sin theta 3, which in terms of I mean summation form, you can in general write like this, sin theta I. Okay, so it doesn't matter if you have 3 4, everything you can do, everything you can find out using these general formulas that we derived here, right? So these two formulas, you know, from here we, for two waves we got these equations, but in general we can use this formula or equations for any number of waves. So that you have to understand, and then you can find out everything. So everything is given here. A1 is 8, A2 is 12, A3 is 20, theta 1 is pi by 3, theta 2 is pi by 4, and theta 3 is pi by 6. Now someone will say, sir, the here omega t, I mean pi by 3 minus omega t is here, so the theta 1 should be minus pi by 3. But it doesn't matter, because, oh sorry, it will matter, because this is cos and this is sine. So for cos is okay, then for sine it will be minus pi by 4. You understand?
Yes.
Because uh, cos minus theta is equal to cos theta, but not for sine, right? So for sine you have to write this pi by 4 is will be the phase will be minus pi by 4. Okay, is this fine? Because in our derivation we wrote this in omega t plus theta 1 form, right? Cos. So that's how we derived these formulas. But here in this problem, you see, it is phase theta 1 minus omega t in this form. So you have to understand what is the theta phase angle here. If there is a sine here, a sine function is there, then you have the phase will be negative. Okay, if it is written in this form. Or you can better you can convert it in cos. So you can write the E2 as 12 cos, so pi by 2 minus, so you know how to go from sine to cos, right? Just you have to shift by 90 degree, right? So pi by 2, so you can shift like this, and what you will get is 12 cos pi by 4 plus omega t. Okay. So now you see the phase angle is because you have to write it in you have to take negative odd of here, so minus omega t minus pi by 4, right? So the phase angle is theta 2 is minus pi by 4. Okay. Yeah, so just to keep this in mind, if you have sine and cos, then this formula will apply only when you either convert all of them into a cos function using this pi by 2 shift, or you have to use a negative sign. If there is a sine function, use just negative to the phase angle. And then you know everything. You can these two equations are there. You put everything, two equations, two unknown. You can easily find out. So let me just quickly write this. So if you put everything in first equation, a cos theta, you will get 29.81. A sin theta, you will get 8.44. Okay. If you will square both of them and add, you will get a square equal to on the right hand side you will get 960.2, and if you take square root you will get 30.98 something, and if you divide them you will get a tan theta is equal to 8.44 divided by 29.81, which is nothing but 0.283. Okay. A will cancel out, and theta is tan inverse of 0.283, which is around so it will be around 0.08 pi. You can check the exact value. So you get the phase angle and the amplitude. Okay. So the resultant or superposed wave will be nothing but, so you can write it like 30.98 cos 0.28 pi minus omega t. So this will be the superposed wave. Okay. So here the tricky part was this sinusoidal function. Instead of cos function you have this sine. So that's why this theta 2 will have a negative sign, because you have to convert it into a cos using the pi by 2 shift. Is this fine?
Yes.
Okay, thank you. Okay, then let's move to the next problem. Okay, the resolution of the image is not good here, so I'll write it out. So again this is through this problem we will discuss a very important concept of interference. Okay, so here two waves are given. So x1 a1 cos omega t plus theta 1, and x2 is a2 cos omega t plus theta 2. Okay, and using the superposition principle, you know that we get this wave function, right? Now there are these options, okay, which have different different conditions. So it's saying that first option is if theta 1 minus theta 2, so the phase difference is pi, and pi or 3 pi and something, and like odd multiple of pi, and amplitude is a1 minus a2, then you will have a constructive interference. So what do you mean by constructive and destructive interference? Everyone knows what is constructive and destructive interference? Okay, let me explain very briefly. So like I mentioned in the beginning, so you have, if you have a two waves, okay, so something like this, and when you add them up, if their phase is shifted, what will happen is, so at a particular point, so let's say here, what happens is, see, at this point, this wave has this height, okay, this much height is there, and this has, it has no, it is 0, right? So when you add them up, uh, the new amplitude that you will get will be just equal to a1 plus 0, okay. But at a different time, you can see, so let's say, actually I've drawn them very badly, but let's say here, yeah, here the amplitude is suppose a1, and here the amplitude is minus a1, right? So the resultant amplitude is a1 minus a2, which will be 0. So here the destructive interference, so this is called a destructive interference, okay. So this is nothing, but this is destructive, and somewhere you will see that, like at this point, the amplitude is a1, the amplitude is a1, so the resultant will be a1 plus a2, which is 2a2, and this is called constructive interference, okay. So what will happen is, at some point the wave get enhanced, and at some point it get diminished, okay. So something like this. So some points will have a constructive interference, some point will have a destructive interference where the height decreases, okay. And so this is the reason you get this interference pattern in the light, the young double slit experiment, if you remember from class 11th or 12th, okay. And so that's why it is asking, so from the formula that we derived, these two formula, we can calculate the criteria when there will be a constructive interference and when there will be a destructive interference, okay. So how can we do that? Let's see. Okay, so what was our formula? So the formula was a1 square plus a2 square plus 2a1 a2 cos theta 1 minus cos theta 2, okay. Now if cos theta 1 minus theta 2 is equal to, say, let's say 1, what will happen is, a will be equal to a1 plus a2, right? So this thing, which is a constructive interference, right? And if cos theta 1 minus theta 2 is equal to minus 1, then from this formula, as you can see, you will have a equal to a1 minus a2, and there will be a mod. So something like this. So a destructive interference, okay. And when does this conditions hold? So theta 1 minus, so cos theta 1 minus cos theta 2 equal to 1 will always happen. So when does cos become 1? When it is multiples of even integer of in integral of pi, right? Like 0, sorry, yeah, no, 1, yeah, 1 happens at 0, pi by 2, 3 by 2, no, sorry, not on what I'm writing. Sorry, 0, pi, 2 pi, 3 pi, like this, right? So you know the cos. So this is at 0 it is 1, at pi by 2 it goes 0, then again at 3 by 2, and then at pi it goes 0. Sorry, no, wait, sorry, what I'm doing. Pi by 2 it is 0, then 3 by 2 it is 0, and 0, and then this is pi, and this is uh, uh, 3 by 2, 2 pi, yeah, sorry. So one happens at one happens at even integers, so 0, 2 pi, and minus 1 happens at uh, odd integers, so like pi, 3 pi, and like this, right? Is this okay? So from the options you can see which one is correct. So at pi, 3 pi you will have a destructive interference, so D is correct, and at 0 and 2 pi you will have constructive interference, so C and D is correct. Okay, is that okay with everyone? So these two options are correct. Yeah. Okay, so this one was also very so this problem was to just show that from these simple equation you can understand the interference, the constructive and destructive interference between two waves, which will help later when you will study the interference and diffraction of light wave. Okay, then let's go to the next problem. So this one is also a simple application of this the superposition. So basically two waves are given here. Okay, first is, but here the difference is this is a traveling wave. Okay, so now there is a dependence on space also, like x pi by 3x minus 20t plus pi, and the second one is, so one is going in x direction, the second one is going in a y direction. (20t plus pi). Okay, so you see the both are traveling wave, and they are traveling in different direction, and we have to find the superposition at x equal to 5 centimeter and y equal to 2 centimeter. Okay, so what you will do, any idea? So it's the same problem, just what you will do is you will put x and y values in these two wave equations. Okay, and then solve it like we are doing in the previous problems. So for example, uh, if you put x equal to 5 here in this first wave, okay, what you will get is psi, so let's call it psi 1. It will be 4 cos pi by 3 into 5 minus 20t plus pi. This will be equal to 4 cos, so pi plus 5 pi by 3, it will be 8 pi by 3 minus 20t. Okay, so now you see this, so that's why okay, someone has solved it, option 3. Okay, yeah, that is okay. I mean, this is simple, right? You have, but what I wanted to say is, so it doesn't because we derived this formula of superposition, when we derived this, we did not use the the space dependence inside the wave, because you see this space dependence, it is accommodated inside the phase angle. Okay, so uh, so what matters is, because you have to see the interference at a particular point in space. Okay, so you fix your position of the wave, and so when you fix this, uh, what happens is, whatever difference you had, whatever the position of the wave is, it will be contribute to the phase of the wave. Okay, because it will be shifted on the y axis or x axis, whatever. So it will be just like a phase, a constant phase. Okay, and that's what you see here. So this x dependence here contributed just to the phase of the wave. Okay, and similarly psi 2, when you put y equal to 3, y equal to 2 centimeter, yeah, psi 2 will be nothing but 2 cos 3 pi, sorry, 3 pi by 2 minus 20t. Okay, so now you have a1 equal to 4, a2 equal to 2, and you have theta 1 equal to 8 pi by 3, and theta 2 equal to 3 pi by 2. Okay, so and then you can use these two formulas to calculate your superposed waves, right? So so amplitude will be, I'm not going to calculate it, I'll just write out the answer. So amplitude will be 2.48, and theta will be I think wait, theta will be something like I have not, yeah, it will be like 2.51, I think, or I'll have to, I don't know, I'll have to check. I think I did not calculate it. Yeah, but so this will be in radian, so you can convert it. So I don't know if here it is mentioned in radian, or so looks like option A should be correct, but you can cross check. So Anjali said option 3 is correct. I don't know, it could be. You can check. So you know the formula, right? You can just apply it, these two formulas, and you can use calculator for it. But yeah, the main concept that I wanted to mention here is that whenever you have a space dependence, it just contributes to the phase of the wave, nothing else. Okay, so yeah. Do you want me to do the detailed calculations, or is it okay? Hello? Hello? Are you able to hear me? Sorry.
Hello, sorry.
Yeah, I think there is a network problem or something. I don't know. Okay, then if everyone is fine, then let's move to the next problem. Uh, I'm changing the page, but it's not changing in the. I mean, it's not changing here. So, which page are you able to see right now? Is it the? Is it a new pro?
Fine,
Okay, okay. If this is if the new slide is visible, then it's fine. Hello, guys.
Yes, sir.
Sorry, I think I had some network problem, so I was kicked out from the meeting. But I think everything is fine now. I'll try to again project my slides. Let's see. Yeah, can you see it?
Yes, sir.
Okay, thank you.
Yes, sir.
Okay, I'll turn off the video because of network. So network is slow today. I don't know why, but okay. Let's. So yeah, there are 2-3 more problems that I wanted to discuss. So based on this refractive index thing that we discussed. Yeah. So we already saw this relation, right? That the refractive index, it depends on this 1 by lambda square, right? Where did we discuss that? I think here, yeah, we saw it, right? Uh, so okay, so the question says that the refractive index of a chrome glass can be approximated by this relation, okay? A plus b by lambda square. I think, Anjali, can you mute? Yeah, thank you. So, and the value of a and b is given. Right, in SI unit, and what is asked is find the index of refraction and phase velocity in this glass for uh, lambda equal to 550 nanometer. Oh, everything is given right in this problem, so what have to do? We have to just substitute everything. So n is equal to 1.4658 plus 5425 by 550. So it's in nanometer, uh, but this one is also in nanometer, so I think it's fine. So yeah, so this is a simple problem. You can just work it out. It will be, the answer is this. But what about the phase velocity? So phase velocity, what is the formula? Anyone remember?
Omega by K.
Yeah, I mean that is the formula, uh, but there is no omega given here and k. So
C by N.
yeah, so because we are talking about light, so in vacuum its speed is c, but in a medium it is c by n we have calculated here, so you can just use it. So speed of light everyone knows, around we will use 3 into 10 to the power 8, no problem, 1.4837, so it will be 2.02 into 10 to the power 8, something like this meter. So you see the speed of light is less than I mean what it is in the vacuum. So that means that if the light travels in a medium with a refractive index higher than 1, its speed will be slowed down basically. Okay. So yeah, it's a simple exercise. And okay, so let's move to the next one. Now this one is for a groove velocity. Okay, so you have to calculate the groove velocity of in a crown glass, and the frequency component centered around 500 nanometer. That means omega is given. Okay, and you know, for a groove velocity there is this d omega, so that's why it is telling you that it is centered. So you will have a distribution like this. Okay, the length of the distribution is basically delta omega, and it is centered at omega, which is 500 nanometer. Okay, and the refractive index relation is given, so it is the same, a plus b lambda. A and b is also given. Okay, and you have to find the groove velocity. So how do you do that? Anyone? So groove velocity, for groove velocity we wrote this equation, right? C by ng, this one, where ng is what we called the group index, right? And what was group index? The formula we derived was n minus lambda dn by d lambda, right? And this lambda is the wavelength in wavelength of, you know, light, basically the vacuum, in vacuum. Okay, that is what I mean we can calculate from here. Omega is given, right? So this formula we also wrote it here, this formula. Okay, so using these two formula we can calculate everything. So first first yeah, we can use this to calculate the n lambda, which is 1.5255. so a and b is given here, plus b is 4825 divided by lambda square. So yeah, okay, this 500 nanometer is basically, it's not frequency, it is basically lambda. Nanometer is the wavelength, I mean the SI unit of wavelength is in distance, so it is not omega, it is basically the wavelength is given. So yeah, 500 square, and if you evaluate it, it is approximately 1.54, should be greater than 1 always. Then we can find dn by d lambda for this equation. So dn by d lambda, you have to differentiate this one, so what you will get is minus 2b by lambda cube. Okay, so substitute everything, you will have so 2b, 2 into 4825 divided by 500 cube minus of this, and this if you calculate, it will be around this because uh, this is in nanometer square and here this is nanometer cube, so nanometer to the power minus 1 will be the unit of this quantity. And then you can calculate the group index, which is n minus lambda dn by d lambda. Okay, so put everything. So n lambda we calculated 1.54 minus lambda is 500 into minus 7.72 into 10 to the power minus 5. Okay, calculate it, you will get something like 1.58. So so it is approximate. So see, there is not much difference between the group index and the actual refractive index of this material, just little different, but it is not the same. Okay, it will be same for which case? When it is vacuum. Okay, and then you have Ng, and then you can calculate the group velocity from here, which is C by Ng. C is 3 into 10 to the power 8 divided by 1.58, and you will get approx 1.89 into 10 to the power 8. This is the group velocity of light inside the this cron glass. So just using these two formula, we can calculate everything. Okay. Everyone is okay with it? Yeah, thank you. Okay, then I think this is the second last problem. Yeah, similar kind of problem we have. So now the material is quartz. Okay, and its refractive index has this form, and for two different wavelengths the refractive index is given. So one is 4.64 and one is given for lambda 2 4.63. so for two different wavelength of light the refractive index is given. Okay, and these two wavelengths are also given. So one is 0.65 micrometer and the other one is 0.48 micrometer. And I think, okay, what we have to find is A and B. Okay, yeah, I think this is the problem. So how to do this? So we can write this equation for both values. So 1.4564 is equal to A plus B by lambda square, which is this. So this is equation 1, and for the second one we can write 1.4633 equal to A plus B 0.48 square. This is second equation, right? Now you have two equations, two unknowns, you can easily solve them, right? Should I leave it or should I solve it? Let me know. It is just calculation, that's it. So it's a very simple problem, just you have to use the formula basically. Is it okay? Should I leave it?
Yes, sir.
Okay, I will write the answer. So A you will get 1.4481 around, and B you will get 35 into 10 to the power minus 4. Okay, so option D is correct. So yeah, try to solve it if you want, you will get the answer. Okay, so now this is the last problem, and this is a very interesting one, conceptual one. So okay, so let's go through it. Now the question says an electromagnetic wave of angular frequency omega is propagating in a medium in which over a band of frequencies the refractive index is given. Now what does it mean, over a band of frequencies? So By the way, uh, here is a typo basically. This is not omega, this should be n. N as a function of omega. Yeah, this is given. So, n as a function of omega, it is given to you. Okay? This is fine. And what you have to find, so omega naught is a constant. Omega is the frequency of the light of the electromagnetic wave, and the dependence of the refractive index on omega has this form. Okay, and you have to calculate the ratio of group velocity by phase velocity. Okay, at frequency omega naught by 2. So this you have to calculate. So it's an easy one, right? So what is phase velocity? Phase velocity is omega by k, right? So you know, so omega, we know omega is given omega naught by 2. What about k? How do you calculate k? Anyone? K is not given, right? But you can write K in terms of what?
N omega upon C.
Yeah, great. Thank you. Yeah, so you can write K equal to n omega by C, and omega is omega naught by 2C. Okay, so you substitute it here, and omega naught get cancelled, 2 get cancelled, you say get C by n omega. Okay, n omega is given here in the problem. So this is your phase velocity. Okay, or more explicitly you can write it like this. Fine. Now what about the group velocity? So this is d omega by dk, correct? Again, since in this k is not there, so we have to convert it into in terms of either n omega or omega, like we did while we were deriving the formula. So just let's invert this. So dk by d omega, and k, we know that it is just n omega by c. So we have to differentiate this in terms of omega, and n is also a function of omega, so remember that. So you will get dn n plus omega dn by d omega, correct? N is always a function of omega, like earlier, and so the group velocity is nothing but 1 by dk by d omega. So c by n plus omega dn by d omega. Now if you take the ratio of these two, phase velocity by group velocity, what do you get? Or first you can compute these two. So basically also you can compute dn by d omega also from here. So dn by d omega, it will be minus 2 omega by omega naught, right? And you can put it here. So now you will get n minus 2 n minus 2 omega by omega naught finally. And then you take the ratio group velocity by phase velocity, So, or what else you can do is you can also calculate these quantities at omega equal to omega naught by 2. So the phase velocity, if you put omega equal to omega naught by 2, then what you get is 1 minus half square, right? Which is nothing but so in denominator you have 3 by 4, so you will get 4 by 3c. So phase velocity is 4 by 3c. Wait, sorry, did I do something wrong? 1 minus 1 by 4, this is fine. How can it exceed a speed of light? One minus 1 by 4 is 3 by 4, right? Sorry, 4 by 3c. Oh, okay, yeah, no, it's okay, yeah, this is the crucial concept. Okay, so this is a phase velocity, it's fine. Okay, yeah, 4 by 3c, it is fine. And the group velocity, if you put omega equal to omega by 2, and n you can evaluate here at omega by 2, it is just minus 1, right? No, sorry, n at omega by 2 is 3 by 4 basically, yeah. So c by 3 by 4 minus 2 omega naught by 2, you have 1. So, and this is what? 3 by 4 minus 1. So it is 4 minus did I do something wrong? 3 by 4 minus 1 will be minus 1 by 4, right? It should not be negative. Should not be negative. Where did I go wrong? Okay, wait. So this we have to evaluate carefully. This is 2 omega square will be there, right? Because 1 omega is from here, dn by d omega, and 1 omega is there, so this will be 2 omega square. Okay, yeah, so 3 this will be 3 by 4 minus 1 by 4, correct? Yeah, 3 by, so it will be c by 2, right? No, 4c by 2, so it will be 2c. Okay, and so the ratio Vg by Vp will be 4 by 2c by 4 by 3c, which is 6 by 4 3/2. Yeah, which does not match any options. I think we did some mistake somewhere. Uh, Omega naught is there. Can you spot the mistake? Anyone? Can anyone else try it? It's a simple problem, but somehow I messed it up. Mm. Where did I go wrong? Okay, I can try it again later. I mean, it's a simple thing, right? You can try it, and I think you will get the right answer. This,
Sir,
yeah.
this means like in where n is a function of omega, 1 minus omega by omega naught squared,
Okay.
differentiated it. So omega naught square will be there, na?
Sorry. Yeah. Omega naught square will be there. No, but that is still not solvable, but because from here omega naught square cancel. Okay. But you have 2 by 4. Omega is omega naught by 2, so 2 by 4 is half. Oh, okay, this is half. Yeah, this is half. So 3 by 4 minus half. Yeah, so then you have basically 4c. And so you have 4c, you have 12 by 4, you have 3. Yeah. So D is the correct option. Yeah, correct. Okay, thank you. Yeah, this is okay. But something that is puzzling me is that you see the phase velocity is has the speed, I mean, is greater than the speed of light. Also, the group velocity is also 4 times of the speed of light. Is that possible? I don't know. The group velocity should not exceed the speed of light, as far as I understand. But yeah, I'll have to check. But okay, I think we found our correct option, which is D. So yeah, everyone is okay with it.
So can the phase velocity exceed the speed of light?
Yeah, phase velocity can exceed the speed of light. No, wait. I think it is other way around. I think phase velocity cannot exceed the speed of light, because phase velocity is the velocity of single components of the light, which should not exceed the speed of light. But group velocity can exceed the speed of light, I think. Yeah, because group velocity has no constraint, so relativity does not apply to a group velocity. But yeah, I'll have to double check, because this one is also does not look correct. 4 by 3c means it is greater than the speed of light. It should not be the case. But okay, I think because we are not discussing relativity here, maybe this kind of refractive index is not natural. I mean, for practical purposes, but yeah, for a theoretical problem we can have something like this. But yeah, it should not exceed the speed of light, phase velocity. Yeah. Okay, then anyone has any other doubt? Or any other question you have? Anything that you didn't understand? Yeah, these are simple problems based on these formulas that we simply derived. Okay, so yeah, I think you will be able to solve the tutorial assignment based on these formulas. The question, I mean, there not much complex calculations are there, so yeah. Mm. Okay. Yeah, I'll have to think about it. Why it is going greater than a speed of light? Maybe this refractive index is not correct, or I don't think it exists in real scenario. Because it is because of this that we are having this greater than a speed of light thing. Yeah, I don't know. Okay, yeah, I'll have to check. Mm. Or I don't know. It happens in some materials, some special kind of materials, that the speed of light is greater than c. I I I I remember something like that. I'll have to check. Yeah. Mm. Obviously, in vacuum, the speed of light is always c, but in medium, could it exceed could it exceed c? I'll have to check. Okay. Okay, we can discuss it next time. This is an interesting thing. Maybe for some materials it does. Special kind of materials. I don't know. I'm not a material scientist. So, okay. Okay, then if there are no other thing to discuss, we can close the session today and meet again next Saturday. Okay. Thank you guys for joining. Bye.
Thank you, sir.
Bye. See you. Bye.